Coming to next measurement, next type of microwave measurement is your S parameters, right? We have seen S parameters, right? Now how to measure S parameters, let us see, right? Now measurement of S parameters, here also you will have two setups, right? Now coming to setup 1, RF signal source, nothing but your microwave signal is given to dual DC. Dual DC is nothing but directional coupler, two directional couplers connected back to back, right? Now dual DC is nothing but two directional couplers are connected back to back, and that is connected to device under test, right? Now that is connected to device under test, nothing but for which you want to measure S parameters, for which you want to measure S parameters, that is nothing but your device under test, right? Now this output of the device under test is again connected to dual DC, right? Dual directional coupler, nothing but two directional couplers connected back to back, right? Now this is connected to output of the second dual DC is connected to load, right? Now this is about setup A, right? Now this device under test, now let us assume two port network. For the two port network we have to measure for the two port network we have to measure scattering parameters, nothing but this device has only two ports, right? This device has only two ports. For this particular two port device, right, two port device we have to measure S parameter, right? Either it contains two ports or three ports, any ports. For a normal, whatever, for the normal basic two port device we are measuring scattering parameter. Now coming to setup B, now this first dual DC is connected to load and this is connected to, these two are interchanged. If I compare setup A with setup B, now RF signal source and load are interchanged with each other, right? Now as I have said, dual DC, right? Dual DC is nothing but two directional couplers connected back to back. This is the structure of dual DC, right? Now first port 1, port 2, port 1, port 2, two directional couplers with port 1, port 2. This is till here one directional coupler and till here another directional coupler, right? Now this is port 3 and port 4 is terminated with the resistance, that is normally it is 50 ohms, and here also port 4 is 50 ohms and this is port 4, right? And the isolated ports, right? Port 3 is also isolated and here port 4. Isolated ports are terminated with some that is 50 ohms. This is the structure of dual DC, two directional couplers back connected back to back, right? Now what is S11, right? Now from the first setup A, from the first setup A we can measure S11 and S21. From setup B we can measure S22 and S12, right? Now we have to define these values of a two port network, two port device, right? It contains only two ports, port 1 and port 2, right? Now what is S11, right? Now input is given to your dual DC. Now that input is nothing but your V1, right? Input is nothing but your V1 and V2 is nothing but your, that is forwarded here, that is given to device under test, right? And that is given to V3 followed by V4, right? Now what is S11? Input given from port 1, output collected from port 1, right? Input given from port 1, output collected from port 1, right? Now what is the output that is collected from port 1? V2, right? Output collected from port 1 will be V2 and input given is V1, right? Now the S is nothing but B by reflected power by incident power. Now the reflected power from port 1 is V2 and the incident power is V1, right? It contains some phase shift, that is represented it as phi 2 minus phi 1, right? Now coming to S21, input given from port 1, output collected from port 2, right? Now this device under test is given as same input, that is V1, right? Input given from port 1 and output collected from port 2. Now what is output that is collected at port 2? V3, right? Now this is V3 by V1, phi 3 minus phi 1. It indicates some phase shift, that's why you will get phi 3 minus phi 1. Now this V4 is connected to load, right? Now this is about setup A. Now coming to setup B, now this particular RF signal source and load are interchanged, right? Now what is input here? V4, right? Input is V4. Now what is output of port 2? Input collected from port 2, output collected from port. Now what is output of port 2? V3. Now V3 by V4 into 53 minus 54 is the scattering parameter, that is S22. Now what is S12? Input collected from port 1, input given through port 2 and output collected from port 1, right? Now what is the input that you are giving? V4. Now what is the output that is collected? V2 by V4, right? Now this is 52 minus 5, right? Now this is how to calculate the scattering parameters of 2-port device. Similarly it is followed for 3-port device, right? Now let me briefly explain, right? Dual DC RF signal source connected to dual DC, nothing but 2 directional couplers connected back to back, right? Now 2 directional couplers connected back to back, right? Now that is your dual DC, and the output of dual DC, this is the structure of dual DC. Port 1, port 2 of first DC, 1, 2 of second DC, port 3 and port 4, and these two are terminated with some resistance, that is 50 ohms, right? Now this is given to device under test. Port 1 of device of that particular device and port 2 of that particular device, right? And this is port 2 of that particular device is connected to another dual DC, terminated. The last output of dual DC is connected to load, right? Coming to second setup, the difference between these two is load and RF signal source are interchanged, right? Now it contains 2 ports, right? Now what is the order of S matrix? 2 by 2, S11, S12, S21 and S22, right? It is a 2-port device. Since we will get 2 by 2 matrix, now we have to find out S11 value, S12 value, S21 value and S22 value. Now from coming to setup A, we can measure S11 and S21, right? Coming to setup A, we can measure S11 and S21 because input is connected to port 1. Input is connected to port 1. If you see this, input is connected to port 2. That's why you'll get S21, S12 and S22 under B, right? Input is connected to port 1, that's why you'll get S11 and S21. Now S11 indicates input given from port 1 and output collected from port 1, right? Now what is the input that is given to port 1? V1, right? And output collected at port 1 is V2. V output by input, reflected power by incident power, right? Now coming to S21, input given from port 1, output collected at port 2. Now this is given to port 2. Now what is output collected at port 3? V3, reflected or output power by incident power, right? Now coming to second setup, right? Now this is your second setup. Now we are interchanging this RF signal source with load, right? Now this port 2 is connected to RF signal source. Now here we can get input power is given to port 2. Here we can get two scattering parameters, that is S22 and S12, right? Now coming to S22, input given through port 2. Now what is the input that you are getting from port 2? V4, right? Now what is the output that you are collecting? V3, right? Now we reflected or output by input, that is V3 by V4, right? Now input is V4, input signal is V4. Now what is the output that is collected from port 1? V2, reflected by input, right? Now this phase shift may or may not present, but just remember this voltage value, right? Now this is about the measurement of scattering parameters, and this can be applicable to N-port device, right? Using a dual DC, this can be applicable to N-port device, right?